Hello, everyone. I'm Cassio Melo. I'm co-founder and CTO at Meilynx. We are an AI governance and FinOps platform. The next 10 minutes is about a subject that's become a consistent theme across the conference is how do we measure AI ROI, right? And I want to pick it up where it left off because once you have the cost data, the next question is how do you attribute that cost to your business outcomes? And I'm going to show you a few techniques that you can apply to get that started. One thing that is common to every team that I talk to is they have visibility into their AI spend. They can tell you how much they spent on tokens last month. They can break down by model. They have FinOps fundamentals. But when you ask the question, what value did you get for it? It's a much more challenging question to answer because cost and value lives in different systems. Cost lives in cloud billing, model invoices, vendor dashboards. Value lives in product analytics, CRM tools, revenue systems. Nothing joins them. And until something does, we're flying half blind. Let me make this more concrete with one of our customer scenario, a classic use case. They are a recruiting company out of the Seattle area, and their goal is to help recruiters fill a role. Their cost data lives in Azure, together with all the AI users instrumentation. Their value data lives in Mixpanel. All the recruiter actions like candidate search, result clicked, candidate shortlisted, candidate hired, all of that is sitting in Mixpanel. Last year, through most of 2025, their developer teams were shipping AI features like liberally. And their leadership started to ask, oh, how many more hires we're getting for all this AI spend? And they're also asking, well, if we switch the model to a cheaper model, how does that affect their conversions? So we help them address these questions systematically with 4 techniques that I'm going to show you next. Technique number 1, direct correlation. It consists in assigning a unique ID through your LLM call all the way to your business events. Simple join, no fuzzy matching. It works really well when you control the whole LLM instrumentation through your business outcomes. It works really well also for agentic workflows because most of the case you are already orchestrating your agents. So it's relatively easy to feed a correlation ID to your agents. But what happens when you don't have control or you can't instrument either or both sides of the systems? Let's say your LLM system is through a vendor and you can't control, you can't instrument that, or your value data is sitting in a CRM system, for example, and you can't really instrument that either. Here's where the temporal and session correlation can be really helpful. And essentially, you join on 3 things: the user session, a time window, and the page or feature that the context is situated. Now, it's an approximation. You gotta validate this with a small data set that you know the results, and you can fine tune your window. It's more like a probabilistic model, and it's okay for directional FinOps decisions. It's not for don't oversell precision, just directional FinOps decisions. And this works really well on legacy systems. You can't really instrument that really easily, or like I said, with systems that are outside your boundaries. Third technique, weighted funnel correlation. This is when a single LLM call can produce multiple subsequent business outcomes. In this technique, you have to assign weights to each one of these steps on those outcomes, right? And your weight assignment is a function of how much AI should take credit for producing that outcome, and also how important that outcome is to your business. So there's no magic formula. It's just a business decision, not technical decision. It's a business decision. In our recruiting example, we have a single LLM call produce search results in which the recruiters can then take subsequent actions to that, like, for example, search, click, contact, or hire. This allows you to measure the cost per outcome, not only cost per LLM call. So you break it down per each one of those stages. Technique number 4 is the one that most teams miss. It's when correlating costs, our tendency is to count the wins, just the events that led to a positive outcome. But if a user interacts with your AI and walks away without a click, that's not missing data, that's a signal. So it's really important that your systems, your LLM calls eventually reach one of the 4 terminal states here: the success, abandoned, rejected, or output unused. There is another state which is pending, which is a temporary state, and you should exclude that. Now, to achieve this, you need to set a session timeout where you explicit emit one of your terminal events. So it's really, really important that when you calculate the cost per outcome, that you factor in all the terminal events, not only the positive, but also the negative or the abandoned or not used ones in the denominator of that equation. Once you have a correlation of any sort, this is the type of things that you unlock. This is a graph that shows the AI spend as a blue chart, blue bars, and the orange line is the cost per positive outcome. With this metric, our recruiting company found 2 things. One, they switched a model, a flagship model, to a cheaper model, and they realized that even though the AI spend was down, their outcomes were significantly down. So the savings weren't really worth it. The second thing, and more interestingly, they figured out that some of their prompts had up to 52,000 tokens because they are augmented by database search in a non-deterministic way. And all these huge prompts, they did not contribute to any positive outcome. So they were able to significantly trim down in a controlled way, observing the cost per outcome and the successful outcomes. And they had the same outcome rate, but lower spend because they trimmed the context down. Now, this is a classic funnel chart. The blue bars represent the number of sessions, and the orange line represents the average cost per session in each stage. Now, you can see the average cost per session remains about the same, but 2/3 of the users drop along the way. So they were paying the same amount of money, but for 2/3 of the events that didn't produce any outcome. So when they looked up in their search results, they found a bug that the search was producing, the AI-powered search was producing some bogus results, that the good candidates in that search, they were way down in the list. So they tweaked the algorithm, and they were able to get that the positive outcome up while keeping the spend relatively the same. The other thing that they did, which I found interesting, is that they set up budgets per outcome and alerts whenever the cost per outcome was rising. Like typically you set budget for AI costs, right? But they went further and set a budget per outcome, and they get alerted whenever that cost per outcome is increasing because they have, for example, bad prompts, or because they are switching to a different model that has different accuracies. So if any of that resonates with you, I'll be around here. I'm happy to chat. I'm happy to follow up with any questions that you may have. I'll be here during the snack break. Thank you.
Hey everyone, producer Andrew here. Thanks for watching. Check out the rest of our channel for more FinOps content. Like, subscribe, and leave questions and comments for our speakers. We appreciate your support.